Hi my friends, today we model this part which is a mud gourd. You see it is a sheet metal part and the source for this was this one. As you can see, this is our part which we want to model today. The drawing is this one, and you see we have a flat pattern, and this is something new for you because I didn't start with the flat pattern but only with the drawing of the folded part. We have here dimensions. The thickness is 1, so we can start. And after the flat pattern was created, we'll apply some cuts. Let's go to the Inventor sheet metal part, start sketch, XY plane, and if you take a look careful to this object, this is our object or subject for the beginning. You see an ellipse here, an ellipse which is 60 on 208, a quarter of an ellipse. The distance is from the center point. I'll place center point here, and the dimensions are 20 millimeters on this direction for one end of the ellipse or segment of ellipse, and the other is here. So we start with the ellipse, my friends. An ellipse is in the circle tab, and we select it from here. We have to draw an axis, horizontal, not this, but this, and the other one. As you saw, the dimensions of this ellipse are 60 twice, 208 twice. So I place dimensions by using what an ellipse offers to us. If you select this contour, you have possibility to place both dimensions. 60 is this one, and everything will be scaled. Home, you see, everything was scaled, and the other is this one, which is 208. We draw a tangent, you see, like we do with circles, we can do with ellipses. I wait for having a perpendicular or vertical line. I apply the dimensions of 20, and then I make the same thing with another dimension. I start from the ellipse, I press the button, and I go around this ellipse. When I am horizontal, I stop and I apply escape. 22 is the other a small line. Good. Now I cut with trim. I trim this external unuseful parts from this ellipse, and I place on the same horizontal this end with this point, and I move all the drawing by using this point to the right, because we have a distance here, as you can see, 400 minus 208 minus 22 minus 50 to have a measure from this point. You remember, yes, all these dimensions. 400, 208, 400 is plus 208, 22, 50. Good. Dimension from this point to the center point is 400 minus 208 minus 22 minus 50. Okay? Good. Now we go to the other lines. As you can see, this 22 stops here. So I can draw a vertical line and then this contour, but as I see here, since we don't have any angle between these two lines, I suppose they are perpendicular. Let me see if this is true. This line with this line are perpendicular. Yes, they are. We have dimensions here. Then we go, as you can see here. Let me draw a circle in the center point. Circle of 50. Radius, you see radius. You can select diameter, but now it is already fixed, the radius 50, and we draw lines and arcs. Line, perpendicular, sloped, perpendicular on the sloped line, vertical, very small. I keep pressed the button, I go here somewhere, and I go to tangency here. As you can see, this must be constrained with tangency. Tangent between this arc and this line. Good. Now you see some fillets. 12. 1, 2, 3. And this is 50 and this is 26. Let's apply 50 for this beginning, and then 12. 50 is for fillet. 50. Between this and this. I hope there is a small vertical line here. Then I change to 12 to apply 1, 2, 3 other fillets. Escape. I move this. No, I place angles. I place angles to have something solved 40 degrees divided by 2. I need to draw this line. Then 27 divided by 2 from this axis. And this is perpendicular. 40 divided by 2, 27 divided by 2. I draw that axis from this point to this point, and I make it construction line, not center line. Trim the circle for the start, and then angles 27 divided by 2. 27 divided by 2. Good. And this small line with the axis is 40 divided by 2. Very good. Now you see a problem. Yes, but if I apply a distance here, or I move this, and this line, I have this distance okay. Let's see what are dimensions. 260 divided by 2 is from this point to here. 260, yes? 260. And 45. Don't forget. This axis and a point which is this one. When you see that icon, you apply 260 minus the divided by 2. And the distance between these two parallel lines is 45. Oh, this is good. I wonder if this endpoint is on the same vertical with this point, because it can be not. Let me try to apply, not the selection, but the 2 points. No, it was not on the same vertical, and these two must be on the same horizontal. We applied trim, and this changes things, like in my previous tutorial, you remember. Okay, the other dimensions are this from end to end, which means this line to be 400. It was already placed. I don't know which one is missing. Oh, this radius. This is 26. 26. And this is radius 50. I suppose it was placed there. 26. Dimension 26. And the last one, I don't know which one is, so I apply automate or auto dimension. Auto dimension. Apply. You see this line? Oh, the length of this line, or the distance between these 2 points. This is missing. Remove. and let's see which dimension. 16, between the two centers of the fillets. 16. Very good, fully constrained. Now we have half of the flat pattern. We apply mirror to obtain the other half. Mirror of what? Mirror of all these lines. I select it from the right to the left. You noticed, yes? And the mirror line is this. Apply. Many icons of symmetry. Yes, of course, there are a lot. Done. Finish sketch. And now we go to sheet metal defaults to establish the thickness. The thickness by default is 0.5. We change this default by placing our thickness of 1. Okay. Face with the thickness and everything okay. This is the face. Yes. Very good. Now I create a sketch on the face and I draw a line from end to end, not smaller, not longer, but from the point to the point to here. Finish sketch. Why I make this? Because we have to apply bending, folding with the radius 24 by using this line, this midline. Let's do this. The tool is fold. We select the bend line. We see the kind of action. We change the angle to 180 and the bend radius is 24 instead of 1, I suppose. Okay, we have the part. Yes. Good. Let's apply the material, stainless steel, not stainless steel, steel carbon, because we use paints, and the color on red. Good. Next is to apply these cuts. We have here all the necessary dimensions, so we apply 4 slots on a face and they go to the other face. So there are 8 in total. You see dimensions. Each one has a point of reference, 3 millimeters from this line, which is the bend line, the end, the tangent line, and 3 millimeters and 137 from the end of part. Radius 2, dimension of 8 is to apply to both. 20 is the distance, 20 degrees for this and 8 degrees for this. Dimensions, reference dimension is 50 on 17. Let's apply these slots. We select this face, we go to slot, This is in the tab with rectangle, slot center to center, and we draw the first one, which is this one. 8 millimeters is the angle between the axis and the face. 8 millimeters. 3 millimeters from the tangent line to the center. And 2 millimeters is the radius. 137 is from this center to the end of part. The end of part is this line or this point. But I have to project it to have. I project this generator and I have the end. Dimension from this point to the center point, which is here. 137. We apply the dimension of 8 to this line, 8, and we have a fully constrained sketch. Then we can apply copy of this contour, copy, paste. I move the new anywhere here, but we have to respect something from this center to this center. I draw a line, I make it construction line. We don't need it to apply any tool. And I apply perpendicular between this line and the center line. You see the sign. The distance is 20. Fully constrained again. I want to make something to be more visible. I don't select red, but I clear everything. Double click on sketch and we continue by looking better at the drawing. We select these two slots, we apply copy, and we place it, paste, we place them somewhere here. The angle now is 20 of this midline, 20 instead of 8. The distance of this point to this line is 17, and the distance from this point to the tangent line is 50. We have fully constrained sketch. Finish sketch, cut, and we select the slots one by one. We don't need to keep pressed the key Shift. And then we select not the thickness is the total depth, but all. We go through the part to the other face, to this face. Okay. You see? Now we have the slots. Good. The last features are two holes. These two placed on the axis, 115 and 20. These two holes, yes. Good. Let's apply the plane. We select this plane, which is somewhere up from the part, you see. So we can use it for placing points. I draw a line from the midpoint of this line to the midpoint of this arc. But again, I have to project this geometry to have it active line from the center to the midpoint right here. Then I place 2 points on the line. I place the small dimension firstly, which is 20, and then the larger, which is this 150. Finish sketch. Now hole through the part with the dimension of 4 millimeters. Okay, let me see. Yes, 2 holes of 4 millimeters. I go back to the color red, and this is the part. Let's see what is the volume. High properties, physical, update, and we select the value. Close, double click, space, paste. My friends, it is right. Same. Cancel. Well, that's all for today. Thanks for watching. Bye bye.